What is WMI? Windows Management Instrumentation is a system for remotely obtaining management information and in some limited cases for reconfiguring management information or settings. WMI is based on a set of industry standard techniques and storage practices. The information is represented in what's called the Common Information Model, or CIM, and all of this was put together by a group called the Desktop Management Task Force, or DMTF, an industry group that Microsoft is a member of. Now, where is WMI? It's been implemented as a service since Windows 2000, and it was available even for NT4. That's how far back it goes. It even runs on Windows Server 2008 Server Core. So it's pretty widely available, and it does allow for remote accessibility, remote connectivity, remote management. So let's take a quick look at how WMI works. Here's a quick overview of how WMI works. This is you on your client workstation, and out on the network is a server, which has a WMI repository and runs the WMI service. On your workstation, you issue a WMI query. This is transmitted to the server, which receives it and processes it. The results of the query are then transmitted back to your computer, where you can work with them. The top level in the WMI structure is a namespace, and a namespace typically aligns to a major product area like SQL Server or IIS or Active Directory or Windows itself. Within namespaces, you have classes. These live inside the namespaces, and they represent the actual manageable components, things like disks or users or mailboxes or websites or whatever else. Classes, though, are abstract descriptions of those things. In other words, your computer has a class for a battery, even if it's a desktop machine that doesn't actually have a battery. So an instance is a real-world occurrence of a class that actually exists on your machine. So if you have two logical disks, then you have two instances of the disk class. If you have no batteries, then you have no instances, although the class in abstract still exists on your computer. Now, classes and instances. Instances are objects, and I told you we'd be coming back to those objects things again. So they have properties, and they can also have methods, which means that you can do things with them. A disk, for example, might have a defrag method, which tells it to take that action. So you review properties to look at management information, and typically you execute methods to make things happen, including reconfiguring things. There are a couple of options for working with WMI. I call them query options. Option 1 is to get all the properties for all the instances of a given class. Option 2 is to get all the objects that match a particular query written in the WMI query language or WQL language. In both cases, Windows PowerShell provides a commandlet called getWMIObject that's actually going to do the work. Let's take a look at it. Here's the simplest way to work with WMI. Run getWMIObject and specify the class name you want to retrieve. You can optionally specify alternate credentials and a remote computer name if you like. This will retrieve all instances of the specified WMI class. So let's see that in PowerShell. Again, here's the easiest way to use WMI, not only from within PowerShell, but the easiest way to use WMI ever. Just run getWMIObject, specify the WMI class that you want, and Windows PowerShell will retrieve all instances of that class as shown here. You can also use its alias, GWMI, and specify a computer name to retrieve WMI instances from that computer. This is the main capability in PowerShell version 1 for remote management, in fact. If you review the help for this commandlet, you'll also see ways to specify alternate credentials when connecting to remote computers. The trick to using WMI, of course, is in finding out which class you need to accomplish whatever you're trying to do. So, of course, the trick here is that you can probably do anything with WMI, or at least a lot of stuff, if you can figure out what class to use. So where do you get a list of classes? Well, for the core root cmv2 namespace, which is where all the Windows operating system functionality lies, you could use the WMI documentation. Or you could just ask Windows PowerShell. I'll show you. PowerShell can actually help you review available classes. In this example, I'll use getWMIObject again, but I'll specify a particular namespace and the -list parameter. The result is a list of classes from that namespace. The ones with an underscore in their name can be ignored. Those are usually system classes. So At the bottom of the list are the classes I'm most interested in, which may have some administrative capability. You can also use tools like this WMI Explorer, which is included on this disk. It lets you browse WMI to see all of the namespaces, classes, and more that are available on your computer. Be sure to run it as an administrator, especially on Windows Vista and later versions of Windows. The WMI query language, or WQL, is available to write very precise queries to WMI. It uses a syntax that's really pretty similar to SQL, so if you've used that, then WQL will seem familiar. You basically specify the properties you want, the class you're querying, and if you like, some filtering criteria to remove instances you don't care about. Here's the basic syntax, along with an example. You start with the keyword select, and then either specify star for all properties, or you can create a comma-separated list of properties. Then the keyword from, and the class you're querying. Finally, and optionally, you can specify the keyword where and a comparison of some kind. Only instances meeting your comparison criteria will actually be retrieved. For example, select all properties from the Win32 logical disk class where the drive type property is equal to 3. Before I use a WQL query in PowerShell, I like to test it first, so I know what I'm getting back from that query. And the best way to do that is to use the built-in WBEM.exe GUI tool. Trust me, it's on your operating system. All you have to do is click Start, Run, type WBEM test, and hit OK, and it'll pop right up. You then connect to a namespace, such as root/cimv2. That's the default namespace used by PowerShell. You then click the Query button, type a query, click Apply, and you review the objects that come back. This is an interactive way to work with WMI, and it lets you figure out what's going to happen before you start relying on a particular query in a PowerShell script. Now, if you have a WQL query, you can execute it by simply running getWMIObject, specifying the query parameter, and providing your query as a string. You can specify a remote computer and alternate credentials too if necessary, and don't forget that getWMIObject has an alias called GWMI, and that the query parameter does not need to be spelled out in order for PowerShell to figure out what you want. Usually -Q is all you need. Writing WQL queries can take some practice, but this basic pattern should help you get the job done. getWMIObject -query, and then the complete WQL query contained within quotation marks or as a string variable. Select, then the properties you want. I selected all properties using star. Then from, and then the class name, Win32 logical disk in this case. Finally, you can add a where clause to restrict which instances come back. I've asked just for those where the drive type property is equal to 3. Now, here's something that confused me a lot at first. A WMI query can potentially return one instance of a class or many instances, depending on what you've queried. For example, Win32 logical disk could return one logical disk or multiple, depending on how many you have on your system. Either way, what you get back is usually a collection of objects, even if that collection only contains one object. This is important because whatever object you get back might not be the actual WMI object you want, but instead might be a sort of container for the collection. So, no matter how many objects you expect to get back, you have to enumerate through the collection to get the actual WMI objects. I'll show you how in a little bit. Now remember, getWMIObject returns objects, and they have properties, which means you can pipe those objects to getMember to see a list of the properties, or you can use those objects in the pipeline with commandlets like sort, select, and measure, and everything else that we've been looking at. These are real functional bits of Windows. So you don't have to just rely on a text list. You can actually work with them. Let's take a look. WMI objects work just like any other in the pipeline. I'll get all of the Win32 logical disk instances and then sort them on drive type. The result is a sorted list. Next, I'll use GWMI to execute a WQL query, selecting all properties of the Win32 logical disk class where the drive type equals 3, and then piping those to select object to just keep the first two. As with any other pipeline, whatever's in the pipeline at the end goes to out default, which converts the objects to text and produces the result that you see here. Please pause this video now and follow the instructions in your lab guide to complete this lab. There are hints in the lab guide if you need them, and try to complete the lab without referring to the solution in your lab guide. When you're done, resume this video and I'll review a sample solution with you. Let's go over lab 7-1. Now, I can't show you task 1 in the shell, but a solution is described in the back of your lab guide, so be sure to refer to that. For task 2, I simply ran get WMI object Win32 logical disk. That displayed a list of all logical disks that my computer has. For task 3, I started with the same command, but piped the Win32 logical disk objects to sort objects and sorted them by drive type. For task 4, I used get WMI object to retrieve the Win32 service class, and I asked it to apply a filter so that only services with a state of running would be returned. This is a bit tricky and it can require some experimentation. Notice that the filter criteria is in double quotes because PowerShell sees it as a string, but the word running is in single quotes within that. That's because the entire criteria needs to be passed to WMI as a single string, but the WMI service needs to see the string running in quotation marks too. And this is just a part of WMI that you kind of have to get used to. For task 5, I started with the same command and piped the objects to select object so that I could just get their name in their start mode. Now in task 6, I used a WQL query, selecting all of the Win32 logical disk instances that have a drive type of 3. You'll notice that this has the same effect as if I'd used the -filter parameter, and you're free to use whichever of those syntaxes is easier for you to remember and use. Finally, for task 7, I used a query to select specific properties, the build number and service pack major version from the Win32 operating system class. I could have also selected the entire Win32 operating system class and piped it to select object to select the properties I wanted. That's probably a more PowerShell to do it, and this is more of a WMI way of doing it. Again, use whichever way makes sense to you.